Nearly all the numbers we work with, both in science and in daily life, represent an amount of something, and we describe that something by stating units, such as meters, kilograms, or seconds. Units provide crucial context to numerical statements. For example, if we say that an item costs 100, it's quite different if we're talking about dollars than if we're talking about pesos. You should always show the units of a problem as you solve it. A simple example will show the idea. Suppose you drive 100 miles in 2 hours. It's probably obvious that your average speed is 50 miles per hour. But let's see how we get this answer by working with units. We start by dividing the 100 miles you drove by the 2 hours it took. Notice that we show the units clearly using abbreviations to save time. Also notice that we use the same abbreviation whether a unit is singular or plural. MI can mean mile or miles, and HR can mean hour or hours. To find the answer, we first divide the numbers. 100 divided by 2 is 50. But 50 alone is meaningless without units. To find the units for our answer, we must also carry out the operations on the units in our equation. In this case, we divide miles by hours, which gives us the final units of miles per hour. 4 key words are helpful in figuring out the units of a problem. Our example shows the first one already. Notice that we read miles divided by hours as miles per hour. In other words, per implies division. The word of usually implies multiplication. If you buy 10 apples at a price of $2 per apple, we write the equation as 10 apples times $2 per apple. Again, we replace per with division, and this time we also replace of with multiplication. The units of apples now cancel, so the answer is 10 times $2 or $20. The dollar sign represents the final units of dollars. You're probably already familiar with the last 2 key words for units, square and cube. Square implies raising to the second power. For example, the area of a room that is 15 meters long and 10 meters wide is its length times its width, or 15 meters times 10 meters. Notice that we've abbreviated M for meters. Now we multiply the numbers 15 times 10 to get 150, and we multiply the units meters times meters to get the final units of meters to the second power, or meters squared. Similarly, cube implies the third power. For example, the volume of a cube that is 1 centimeter on a side is its length times its width times its height, or 1 centimeter times 1 centimeter times 1 centimeter, giving us the answer 1 centimeter to the third power, or 1 centimeter cubed. We now summarize our key words for working with units.